The next toolkit entry for Chapter 7 is called the Triangle Midsegment Theorem. And finally, we're getting away from all the properties of all the different polygons that we've been looking at so far this chapter. So go ahead and draw a picture of a triangle in your toolkit. So it looks something like this, triangle A, B, C. Don't worry, the sides don't have to be equal in length or anything like that, but just draw a picture that looks something like that here. And basically, by definition, a midsegment is a line segment that connects the midpoints of any two sides of a triangle. So for instance, let's say I said that this is point P, and I made it the midpoint of this side. Would that mean that BP would be the exact same length as PA? So that means these two line segments are congruent to each other here. Let's say on the other side I drew in Q, and let's say it was right here. And there's Q, and that would mean that BQ is the exact same length as QC because I'm making it the midpoint there of these two sides. If I were to go ahead and connect those, so I'm going to go ahead and connect those right now, I would form what we call the midsegment. So PQ would be the midsegment here of the triangle. And actually, as it turns out, every triangle has three midsegments. That's just one of them, and I'll show you what that would look like in a minute here if we drew in all three. And what happens is this. There's a few things we know about a midsegment. Number one, we know that they're half the length of the third side. So that means PQ is going to be half the length of side AC. Or another way of looking at it could be if you take twice the length of PQ, whatever that happens to be, it would equal the side on the bottom, side AC. So for instance, I'm just making this up here, if this were 14 from A to C, that means from P to Q it would be 7. Okay? The other thing you should know is that midsegments are not only half the length of the third side, but they're also parallel to the third side. So that means this midsegment would be parallel to AC. All right, so that's kind of how it all works there in terms of midsegments and so forth. So let's try a few problems here involving a bigger triangle. And in this case over here, what you'll see is that all three midsegments are drawn in. So DE is one midsegment, but also DF is well, and so is FE. So if we said that the length of DE is 8, so where is DE? So let me go ahead and highlight that right now. So let me grab the highlighter. So DE would be right here, and it says how long is AC? So basically in this case here, what we know is that we know DE is 8, and it's the midsegment of AC. So therefore AC would be twice that, so it would be 16 long. So we would say 16 units. Okay, so that's the first answer here. Now what if we said BC equals 40? Could you figure out DF? So first of all, let's kind of draw those figures in here. So BC, where is that? Oh, here's BC right over here. So I'm going to go ahead and draw that in. There's my BC. And here is DF right here. And so we'll see that BC is the long side and DF is actually our midsegment here. So we know that BC is 40, so we know that this entire length is 40, which means that DF is its midsegment, so it should be half that. So it should be 20 units. So that would be our answer for that one. Sometimes in the class you'll be actually given a scenario where you actually aren't given actually a length of one side or a midsegment, you have to figure out the other, but it'll involve variables here. So let's say in this case here it says solve for x if AB equals 3x plus 4. So AB, and I'm going to go ahead and draw that in here again, AB would be from here to here. So AB would be 3x plus 4 all the way from here to here. And likewise, EF would be 20. So that's the midsegment over here. That would be 20. So here's what we know. If we were to take EF, whatever it is, and if we were to double it, it would equal whatever the length of AB is, because EF is the midsegment here. And so we know EF is 20, so we're going to go ahead and replace that with 20. So we'd say 2 times 20 equals the length of AB. Well, how long is AB? Well, AB is 3x plus 4. Now it's just an equation. We can go ahead and solve this here. So 2 times 20 is 40. So 40 equals 3x plus 4. We can go and subtract 4 on both sides. So now we get 36 equals 3x. And finally, if we divide by 3, we would get x equals 12. So our answer in this case here, because we're asked to solve for x, is x would be 12 units.